along a straight road to town Y. Okay, so here we have X and here we have Y, and it travels there 40 kilometers. The driver then turns around and immediately drives back to town X. The whole trip takes 2 hours. Okay, so time, 2 hours. The magnitude, what does the word magnitude mean? Size. The size of the average velocity. Okay, now we stop. Velocity, Rory, is linked to what? It is linked to displacement. Oopsie, displacement. And displacement, delta x, is a vector. Displacement is the direct line between start to finish. Okay? These are things that I've said every time we've used the word velocity. Okay? So it should pop up in your head. Okay? So I'm going to say again. The magnitude, the size of the average velocity. What is velocity again? It is a vector linked to displacement. What is displacement? The direct line between your start and your finish. Okay, so the velocity for the whole journey in kilometers per hour will be what? Okay, so your question is, what is the displacement? See, yeah? What is the displacement for the guy's car? Okay, where did he start? At X. Where did he finish? At X. So what's the direct line between start and finish? Nothing. 0. So his displacement is 0. Over 2 hours gives you 0 kilometers per hour. So what you guys thought of is, if they ask for the average speed, speed is a scalar linked to distance. Then you would have said 80 divided by 2 gives you 40 kilometers per hour. That is not the question. The question was the average velocity. Sharp? Who got that right? Mooi. Okay. So, did you make these notes as I spoke? Because I know these things. If you got it wrong, it means you did not know this. Yes? Are you awake? But maybe focus on this first. But she cannot make notes at the question. Alright, it says there, the slope of a tangent of a position versus time graph represents. Yo, Carabello, what is the slope of a tangent? Yes, that's my question. Because how can you answer the question if you don't know what the question is? The slope of a tangent. What is a tangent?
What's a tangent?
That's my question to you. Yes, Kali?
The tangent is like a line that almost touches the ground.
Okay, so mooi. It's an Afrikaans is 'n raaklyn. What do you call it in? It's like, I don't know. Hello, wow. Why are you late? What? Every day. You oversleep every day. Then you should change that. Okay. Okay. So if you have a graph like this, okay, it goes up like that. This is distance or position versus time. Then the slope of a tangent is that line there. Like that. You've done that in mathematics? Where it touches at one point? Yes? Not? Yes? There where they intercept. There where they touch. Okay. So that is a tangent line. And when they speak about the slope, they actually speak about the gradient. Oopsie, it's English. The gradient. Okay. Right, so they're basically asking you, calculate what does the gradient represent of a position versus time graph? Okay, and we did that yesterday. We said, okay, gradient is the change in y over the change in x. For this graph specifically, are you making notes as I speak? I know these things. For this graph specifically, it's the x over the t in meters over second. So that gives me meters per second, which is the same as meters per second. Is it acceleration or velocity? Velocity. Okay. So we know our options is either B or C. Either the average velocity or the instantaneous velocity. Retabile, which one will you say? Is it that? There? Does it give you the average velocity or the instantaneous velocity? Average velocity is over a long time period, where instantaneous is a short time period. Does it touch there for a long time or a short time? Short time. So that is why it's instantaneous velocity. These questions all come from past papers. So this is the type of questions you can expect. That's why we're doing it. That's why I'm explaining it. And you'll stop me if you have a specific question. Okay. Next one, it says, a van traveling at a constant speed of 54 kilometers per hour in a 40 kilometer zone. Policeman starts his car from rest just as the van passes him. The police car accelerates at 2 meters per second squared until it reaches a maximum velocity of that. The policeman then continues driving at this constant velocity. Convert that kilometers per hour to meters per second. Cloney, what must you do? By what? And what do you get? I didn't check in. Did you guys check in?
Yes.
Right. Right, so 15 meters per second is quite fast. Okay. Then they ask you in the second question, calculate the time it takes the police car to reach its maximum velocity. Okay, so you have an info table. They ask the time. We need initial velocity, final velocity, acceleration. The acceleration of the police car was 2 meters per second squared. Its maximum velocity that it reaches is 20 meters per second. Bukamuso, what was the initial velocity of the police car? Yes? No? That's its maximum velocity, its final velocity that it reaches. Say again? No. That 2 is 2 meters per second squared. That's its acceleration. Please read from here out loud.
The policeman starts his car from rest. 0.
Dankie. You need to fill in that 0. I want to see that 0. You can't just say 20. You must say 20 minus 0. Alright, so then the t is underneath the fraction. You don't want it there. You take it up. And then the 2 goes down. And then what do you get, Lesedi? Without a calculator. Dankie. 10 seconds. Okay. Then you can't do question C just yet. Okay, so that we put in brackets for a bit later. Alright, you don't have to do question 4 yet. Not that yet. Question 7 says, a brother and sister walks home from school. After walking 500 meters eastwards, the brother realizes that he has left a book at school and he returns to school. His sister continues walking another 800 meters to their home. She travels home. She arrives home 30 minutes after leaving school. Okay. Now they ask, calculate the average speed of the girl from the school to her home. Okay, so we have the girl. How far did the girl walk? Sebabatso. Okay, so we said 500 plus 800 is 1,300 meters. Okay, and the time was how long, Teppo? Do we work in minutes? So what are you going to do? And that gives you? Okay, and they ask for the average speed. So speed is distance over time. 1,300 divided by 1,800. And what do you get, Klano? And the unit? Dankie. Okay, I did say this yesterday. I'm going to repeat it again. Remember this formula. Oopsie. This formula is not on your data sheet. It's something that you have to go memorize. Also, this formula, not on your data sheet. Have to go memorize it. Okay. Dankie. Say slippy gegee. Goed, dankie. Dankie. Here again. Okay. Now they ask, use a vector scale diagram and represent the displacement of the boy from the time that he realizes he left his book at school until he reaches home. Include all relevant information in the diagram, and it says use a scale. 1 centimeter is equal to 100 meters. Okay. Now, let's just do our planning first. The boy walked 500 meters that way. Yes. Then he walked 500 meters back. And then he walked, 500 meters and then another 800 meters until he reaches home. Okay. Now they ask for a vector scale diagram, and they want that represents the displacement of the boy. What is displacement again? Well, the what? Here and informally. That is the formal definition. After that, for displacement, the direct line between start and finish. Yeah, from start to finish. Okay, and they say the scale must be 1 centimeter is 100 meters. So you start with your scale. 1 centimeter is equal to 100 meters. Okay, so this 500 will be 5 centimeters, 5 centimeters, 5 centimeters, 8 centimeters. Yeah? Okay, right. Now, they asked for, they asked for his a vector diagram, and they asked for his displacement. Displacement is a direct line between his start and his finish. So he started there, he finished there. So is it necessary to show all of that? No. Oh, wait. I didn't read the question out loud. No, that is not his start. The question says, from the time he realized he's left his book at school. Where did he remember he left his book at school? There. There he realized he's left his book. So that one is out. Okay? So this is his start, his initial, and this is his end, his final. And you are just going to draw the direct line between his start and his finish, because you need to show the displacement. So you are not going to show this and you're not going to show that. Okay, I'm just going to go through what I just said. They asked for his displacement from the moment he realized he's left his book at school until he reaches home. There he realized he left his book at school. There he reaches home. What is his displacement? The direct line there. So you're only going to draw that line. How long will that line be? 8 centimeters. So you're going to say that it's 800 meters. And what is the direction? East. That's all. If they asked you, if they asked you to show his entire movement, okay, so meaning need to show every single thing, then you would have drawn a big dot there, big dot, and then you would have drawn 500 this way and 500 this way, and then 800 this way. Okay, so if you needed to show everything from the moment he left his book, or remembered he left his book, he went to the left, he went to the right, and he went more to the right, that way. Okay? So just see, when you have to show everything, you make your dot a bit bigger in the middle, and then all the arrows point away from the dot. You can't have 500 this way and then 500 that way. You can't have an arrow pointing towards the dot. Okay. Right. Then they asked if the average speed of the boy is the same as that of the girl. Okay, so we got it as 0.72. Calculate how long it will take the boy to reach home from the time they both left the school together. Okay, so speed is a scalar. Okay, so we have, what was this, 7.7c. Okay, so 7c, they asked for speed, which is a scalar that is linked to the distance that he traveled. The distance that he traveled from school is, he traveled 500, then 500, then 500, and then 800. So what's the average, the total distance that he traveled? 2,300 meters. Ne? 1,000 plus 1,300 gives you 2,300. They said the average speed is the same. 0.72. Okay, and we want the time. So we have velocity or speed is distance over time. 0.72, 2,300 divided by time. Time is underneath the fraction. Gali word wakker. Sit regop. Time is underneath the fraction. You don't want it there, so you take it up and you take the velocity or the speed down. And what do you get? Nee, Kalo. Why do I have such a big number? I have a big number. I have 3,000. Let's just check. They wanted the time. We have that velocity. Well, it's the seconds. Well, okay. I have 3,194 seconds. Are you fine? Okay. All right. Any questions? And was that all homework that I gave you?
Yes.
Okay. Right. Back to your notes. Back to the notes. Okay. So we started yesterday with displacement or position time graphs. Okay. And we looked at how do we calculate, or the gradient gives us the velocity. We looked at instantaneous velocity. Now this page is just a summary of the different shapes of displacement graphs. Okay, so here we have displacement time graph, and they say it must be for a constant positive velocity. A constant positive velocity. Constant tells you that it is a straight line. Okay, so constant tells you it's a straight line. It does not curve. And then they say positive velocity. Okay, so not plus velocity, positive velocity. You went here. Oh no. For a displacement time graph, where do you find the velocity? Huh? No. In a displacement time graph, what indicates, what gives you the velocity?
Meters, which is on the
No, meters gives you distance. Displacement or distance. Here's Courtney.
Isn't it the line that you draw between the two?
The gradient. Okay, so if it tells you it's a positive velocity, then it means, so a positive velocity means that it must be a positive gradient. Okay, can you see how I take this description apart? Constant means it's a straight line. Positive velocity means it must be a positive gradient. So Khali, please show me with your hands. If we have a straight line with a positive gradient, what will that look like? Thank you. Like that. Yes.
Why don't we draw arrows on the end?
That's just not how we do it in science. Because it doesn't mean that it goes on necessarily. Okay. When the object is stationary, it means stationary. It's not the stuff that you write with here. Stationary means that it has no velocity, or that the velocity is 0. If the velocity is 0, Hope, what does that mean for the gradient? The gradient is 0. And Relo, what will a 0 gradient line look like? Show it with your hands. Thank you. Okay. Then we have a high velocity compared to a low velocity. Now, I say a high positive velocity compared to a low positive velocity. So both are positive, but the one is a high velocity, the one is a low velocity. Zora, how will that change in the graph? Like, how do we show or indicate that it is different? you are going to draw true graphs, yes, but like what represents the difference? Like how will it be represented? The gradient will be different. Okay, a high velocity means a high gradient, a big gradient, whereas a low velocity means a smaller gradient. Okay, let's make this number 1 and this one number 2. Then a high gradient will be like something like that, and a lower gradient will something like that. So this means it goes faster, this means it goes slower. Okay, yes.
Didn't you know that they were both positive?
I just said let's make them both positive, yeah. Okay, then increasing velocity and decreasing velocity or speed. Increasing velocity means that you have positive acceleration. Decreasing velocity means you have negative acceleration. Okay, now increasing velocity, the arrow up means or stands for increasing. Increasing velocity means that you must have an increasing gradient, because the velocity here is represented by the gradient. So it's not a constant gradient, it's an increasing gradient. Toto, what will that look like? So not a constant gradient, an increasing gradient. So you say like this. Okay, this here means it goes faster. Not faster, it goes at a certain speed. But this has a constant gradient because it's a straight line. And we don't want a constant gradient, we want an increasing gradient. Meaning that this just means that it's still constant but at a faster speed. Rory? Yes, it's going to curve like that. So that means not a straight line, but curved. Okay, so what will a decreasing speed look like? No, so decreasing speed is me, I'm still running forward, but I'm just slowing down. So it doesn't go in the opposite direction. Yes, mooi. So it's going to curve like that. Okay, so a decreasing velocity means a decreasing gradient. The gradient becomes smaller. So it's curved downwards. Okay, then we have moving forward and moving backwards. Now let's just make this, we say this is at a constant velocity. Okay, because you can move forward and backwards, decreasing speed, increasing speed. Let's just make it a constant velocity. Okay, so first of all, a constant velocity means you must have a constant gradient, meaning straight line. Okay, so our graphs will be straight lines. Okay, but moving forward, let's make forward number 1 and backwards number 2. moving forward means that you are moving in the positive direction. So that means you must have a positive velocity, and that means a positive gradient. Okay, so I'm going to say that again. First of all, constant velocity means it must be a constant gradient, straight line. So straight like this, or this, or this, or whatever. Straight lines. Whereas forward means in the positive direction. Or it means you must have positive velocity, because negative velocity means in the negative direction. So positive velocity means a positive gradient. What will that look like, Arabello? Straight line, positive gradient. Chop. So that's number one. Okay. Whereas number two, we still have constant velocity, but now backwards. Backwards mean in the negative direction. Because remember, velocity is a vector. Vector has size and direction. So backwards means in the negative direction. So that means negative velocity or a negative gradient. Ridabile, what will that look like? Wait. So like that. Okay, so grade 10s. What I can do in a test or in an exam is I can either give you one of these or I can combine them. Okay, so tell you the object moved at a constant positive velocity, then it was stationary, and then it moved in the negative direction backwards. Okay? Or I can tell you the object accelerated and then it moved at a constant velocity and then it came to a standstill. Okay, so I can combine it. Right, so I'm not going to ask these things like this. Don't go study it as a parrot or like a parrot. You're going to do what? Go through past papers. And when you get to a question that gives you different graphs or graphs together, you can then go back to your notes and say, all right, what does this shape mean again? Oh, okay, a straight line means this. Do you understand? Okay, this that we've done yesterday and today is the displacement time graph. Displacement time graph. Now we're going to go to another type of graph. We're going to go to velocity time graphs. Okay, so this is what you did in your practical. You first did a displacement time graph, a distance time graph, and then you did a velocity time graph. Okay, so you've already drawn stuff like that. Okay, so a velocity time graph means or gives different things. Okay, now I want to go here to the bottom. Velocity time. Okay, let's say the velocity time graph that you get looks like this. Right. Your first question from now on until the day that you die. Okay, when you get a graph, you must ask yourself, what does the gradient tell me? Okay, especially in science class. Okay, but also when anyone in life gives you a graph that goes like this, you must ask, okay, why does the gradient go up? Why does it go down? I think you all, if someone gives you something like this regarding money, what does that mean? You made money and then you lost money. And then you made and then you lost a bit. Right? So you looked at the gradient and you see, let's say it was like this and then it was like that. You would have said, oh, here you quickly made a lot of money. Then you lost a lot of money immediately. And then gradually you made more money. Yes? So subconsciously, you know to look at the gradient. So from now on, until the day you die one day, you ask, what does the gradient tell me? So for this velocity time graph, you're going to ask, what does the gradient tell me? Gradient is change in y over change in x. For this graph specifically, the y-axis is my velocity and the x-axis is my time. Velocity, time. Where are we with our question? Flony, what do we measure velocity in? What's the unit for velocity? I'm ready when you are. Okay, meters per second, please. Meters per second. Then, Bukamuso, what do we measure time in? Second. You can, but in science class, we work in meters per second. Okay, let's see. If we have meters per second divided by seconds, what do you get? Okay. Sorry, go again. Mooi. And so what? So meters per second squared gives us what? Say again. Meters per second squared is the unit for what? Displacement is meters. Acceleration. Okay, so what did we just prove? We proved that the gradient gives us acceleration. So for this type of graph, when they ask you, determine the acceleration, then you know, oh, I should look at the gradient. Okay, please don't get confused. For position time graphs, the gradient gives us velocity. For velocity time graphs, the gradient gives us acceleration. So it changes, the gradient changes for each type of graph. Okay. We're going to go to the bottom in a moment. I first want to do this. It says there, the graph shows the velocity of an object over 36 seconds. Okay. Then they ask, calculate the acceleration for the first 10 seconds, 10 to 30 seconds, 30 to 36 seconds. If they ask you calculate the acceleration, you say, okay, where do I find acceleration here in this graph? Oh, acceleration is the gradient. So if they ask acceleration, they're basically asking me to calculate the gradient. Okay, so please don't call me during your test and say, ma'am, there's a mistake on the question paper. They ask for acceleration, but there's nowhere on the graph. You must know. Okay, oh wait, you have homework. Your homework is page, let me just think, on page 23, question 9, question 10, question 9, question 10, question 11 and question 12. So 9, 10, 11 are multiple choice questions. Question 12 is a bit longer.